I'm going to graph this exponential function that has been vertically stretched by a factor of 2. This was also shifted to the left 1 unit, and it was also shifted down 4 units. So before we sketch this, I'm going to go back to the parent function, just 2 to the x. So if I plug in a -2 into this x, I have 2 to the -2. Remember, whenever you have a negative exponent, you must flip the base. So this is 1/2. Once you flip the base, your exponent is now positive and not negative. This is equal to 1/4, also known as 0.25. Okay, next I'm going to plug in a -1 for my exponent. A negative exponent, you must flip the base, and now your exponent is positive. This is just 1/2, or 0.5. 2 to the power of 0 is just 1. Anything to the power of 0 is 1. 2 to the 1 is just 2, and 2 squared is just 4. So this is my parent function, and I'm going to go ahead and graph that. So -2 is at 0.25 down here. -1 is at 0.5. Zero is at 1. 1 is at 2. And 2 is at 4. And you could keep going. You can do 3. 2 cubed is 8. So that would be up here. So this is my exponential function, and it gets very close to 0, the asymptote. Okay, now that we graphed the parent function, we're going to move on to graphing this transformation. And I erased the rest, but I wanted to keep that it went left 1. You want to pay attention to whether it moves to the left or to the right. So since this moved left 1, I'm going to center my table around -1. And I'll use the numbers around -1. Okay, so now we're going to plug our x values into our function. So I'll do 2 times your base is 2. Where the x is, I'm going to plug in a -3. So remember, you have to do order of operations. We don't have any parentheses here. We're going to start with the exponent. Exponents come first. So let's look at this exponent. -3 plus 1 is -2. Now, whenever you have a negative exponent, you must flip this base. So this becomes 1/2, and now your exponent is positive. Everything else can come down. 1/2 squared is 1/4. Everything else can just come down. So we dealt with the exponent. Next is multiplication. So 2 times 1/4 is 2/4, which is just 1/2. And now I'm going to subtract 4. This is going to be -3.5. The last thing that comes in your order of operations is addition and subtraction. So that's why I subtracted last, and I got -3.5. Now let's do the same process for the rest of these x values. Okay, so now I'm going to plug in a -2. -2. -2 plus 1 is -1. You must flip the base and make the exponent positive. 1/2 to the 1 power is just 1/2. 2 times 1/2 is 1. 1 minus 4 is -3. Next, we're going to plug in a -1. -1 plus 1 is 0. Anything to the power of 0 is 1. 2 times 1 is 2, minus 4 is -2. Now we're going to plug in a 0. Okay, so 0 plus 1, that's just 1. 2 to the power of 1, that's just 2. Times 2 is 4. 4 minus 4 is 0. Now let's plug in a 1. I'll do it down here. I'm going to plug in a 1. 1 plus 1, we get 2. So this becomes a 2 up here. 2 squared is 4. Times 2 is 8. Minus 4, we get 4. And then I'll do the 2 last. So now we're going to plug in a 2. Two plus 1 is 3. 2 cubed is 8. 2 times 8 is 16. Minus 4 is 12. So now I'm going to graph my transformation function. Negative 3 is with negative 3.5. So that is down here. Negative 2 is at negative 3. Negative 1 is at negative 2. 0, 0. 1, 4. And 2, 12. 2 and 12 is way up here. All right, so this is my new graph. Now, my asymptote is always this number right here. So since it went down 4, this is my asymptote right here at negative 4. Okay, so let's look at the transformation. It did a vertical stretch by 2. It also went down 4 and it went to the left 1. So let's look at this point right here. Let's look at this one. Or we'll look at this one right here. This point right here on the parent function, this is the point 2, 4. It went left 1, so left 1, it's now here. And this right here, it got multiplied by 2, so it became 8, and then it went down 4. So now it's at 4. So your new point is 1, 4, which is right here on this new graph. So that's how the points transform. This point right here, I'll do this one as an example. This is the point 1, 2. However, it went left 1. That affects your x values. So now it's at 0. Your 2, it got multiplied by 2. So 2 times 2 equals 4. And then it went down 4. So now it's at 0. And look, I have a point right there, 0, 0, that your graph goes through. So that's how the transformations work. Okay, now some important information that we need to go through for all of these graphs is the domain, range, and end behaviors. So your domain, it goes forever to the left and forever to the right. Your range, your asymptote is down here at negative 4. So it's at negative 4, and then your graph goes up, infinity. The asymptote crosses the y-axis at negative 4. So that's y equals negative 4 for your asymptote. The limit as your graph goes to infinity, as the x values go to infinity. So as I move this way, the y values are going to infinity. When I go the other direction, so as I move in the left direction, going to the negative side, my graph is going towards the asymptote as I move to the left. So that's negative 4. This graph is always increasing. As you move from left to right, it's always going up. So it's always increasing. That means it is increasing from negative infinity to infinity. It is never decreasing. Let's try another example. Now I have a 1/2. So let's graph the parent function first. Let's just graph 1/2 to the power of x. So if I plug in a -2, you have to flip it and your exponent is positive, so that's 4. If I plug in a -1, you have to flip it. The exponent is positive, that becomes a 2. 1/2 to the power of 0 is just 1. 1/2 to the power of 1 is 1/2, and 1/2 to the power of 2 is 1/4. So that's my parent function. I'll graph it over here. -2, 4 is right here. -1, 2. 0, 1. 1 and 1/2. 2 and 1/4. So this is my graph. Okay, so this is the graph y equals 1/2 to the power of x. Now we're going to do the transformation. Notice, guys, this went to the right 2. So I'm going to center my graph around 2, and I'll do the numbers around 2. Okay, so let's go ahead and transform it. So this is my graph, my equation. I'm going to plug in a 0. So 0 minus 2, that's just -2. When I have a negative exponent, you must flip the base and make that positive. 2 squared is 4, but you still have that negative in the front. So this is now -4. Now let's try plugging in 1. And let's see what happens. So now I'm going to plug in a 1. 1 minus 2 is -1. You must flip the base. So this is 2, and that becomes positive. 2 to the 1 is 2, but you still have that negative. So that's -2. Now let's plug in a 2. And let's see what happens. Plug in a 2. 2 minus 2 is 0. Anything to the 0 power is 1. And then you have that negative in the front. So that's -1. Now we're going to plug in 3. 3 minus 2 is 1. Anything to the 1 power or the first power is just itself. So that's just -1/2. And now I plug in a 4. 4 minus 2 is 2. 1/2 squared is 1/4. So that's -1/4. And I'll go ahead and graph this. 0, -4 is right here. 1, -2 is right here. 2, -1 is right here. 3, -1/2 is right here. And 4, -1/4 is right here. So notice, that's what my graph looks like. And that makes sense because this negative means reflect over the x-axis. So notice this point reflected over the x-axis, and now it's right here. Then it moved to the right 2. 1, 2, and that's your new point. This point right here reflected over the x-axis. This is the x-axis, and it moved over 2. So now it's there. So that's your transformation. Okay, on the screen, I have the parent function, y equals 2 to the power of x. Those are the points, and this is the graph. Now, what I'm going to do is change this to a -x. So let's see what happens. I'll still plug in the same values because it didn't move left or right, so I can just do my regular numbers. So I'm going to plug in a -2. That negative is already there. That's part of the equation. 2 negatives make a positive, so that's 2 to the power of 2, which is 4. Next, I'm going to plug in a -1. 2 negatives make it a positive 1, so that's just 2. Next, I'll plug in a 0. Anything to the power of 0 is just 1. And -0 is still just 0. put a 1 there. Now that's a negative 1. When you have a negative exponent, you must flip this. So this becomes 1 over 2. So that's 1/2. Next, I'll plug in a 2. Again, negative exponent, you must flip the base. So that's 1/2 to the power of 2, which is 1/4. Next, I'm going to plug in a 3. Negative exponent, you must flip the base. Now it's a positive 3. This is 1/8. Now, I'll go ahead and graph this function. So, -2 is at 4. -1 is at 2. 0, 1 is still at the same spot. 1 is at 1/2. 2 is at 1/4, and it gets very tiny. So it looks like it goes like this. Notice, guys, it reflected across the y-axis. So when the negative is right here, it will reflect across the y-axis. And in our other example, the negative was in the very front. That means it reflects over the x-axis. So it flipped this way across the x-axis. So here are some key things that we have to learn. When the negative is in the very front, it'll reflect across the x-axis, and it's right here. If it's right here, it will reflect across the y-axis. Also, when your base is greater than 1, you will have a growth graph. Let's look at an example. Here, your base is greater than 2. The parent function is greater than 2. So that's why it grew. The parent function grew. And then after it grew, you did these transformations. This example, your base is 2. That's greater than 1. That's why your parent function is a growth, and then you transformed it, stretched it, moved it left, moved it down. This equation, your base was 1/2. 1/2 is less than 1. That's a decay. That's why your original parent function decayed. It went down. And then after that, you had different transformations affecting the graph. Okay? So, key things from today's lesson. When your base is greater than 1, your graph is going to grow. When your base is less than 1, your graph is going to decay. And then, of course, different transformations may or may not happen. The negative in the front will make it reflect across the x-axis. So this is the x-axis in this case. This is the x-axis in this case. If there's a negative right here, your graph will reflect across the y-axis. So then your graph will look like this. All right, that's the end of the lesson. I hope you learned a lot.